Chi-square test for goodness of fit is a test that is used to assess that whether certain discrete distribution such as binomial distribution or Poisson distribution is a good fit on certain real life data. Similarly, we wanted to see that any continuous distribution probability function such as normal distribution or gamma distribution or exponential distribution will be a good fit for any real life data set. So students, basically this test is a non-parametric test. Chi-square test for goodness of fit would assess that whether the observed sampling distribution that is in close agreement with the expected probability function. It assumes that the data under H0, it comes from the multinomial distribution. So there are certain assumptions that we need to test before applying this chi-square test for goodness of fit. The very first assumption, students, you will check is that the sample is a random sample. Then the next assumption is that the variable of interest is categorical. That means it may have certain categories, but with the condition that those categories must be mutually exclusive in nature. That means if one category is coming, that the other cannot come with the same title. Such as we are talking about gender, there are two possible categories for that. One is a male and other is a female. So they must not be overlapping categories. And lastly, we are assuming that the expected frequency for each category must be at least 5. So if these assumptions are satisfied with certain data set, then we can apply the chi-square test for goodness of fit. Now students, इसका जो procedure है chi-square test for goodness of fit का, obviously it is a statistical test, so we need to outline certain procedural activities or the steps for assessing or applying this particular test. The first step you need to follow is to formulate the pair of hypothesis. So students, यहाँ पे H0 है जो आपका वो होगा the null hypothesized proportions for each category are equal or same. And the alternative would be that they are different. And if you remember, we have assumed कि आपका जो H0 है, उसके अंदर जो parameter of interest है, they must follow the multinomial distribution. Step number 2 is to choose alpha, the level of significance. Then the next step is to find out the formulae under test statistic. So students, the chi-square formula is summation of O minus E whole square divided by E, where OI is the observed frequency and EI is the expected frequency that we need to calculate for the sample. And how we can calculate that? Students, this EI is equal to N into PI, where N is the total sample size, the total, and PI is the probability for each category. Now students, step number 4 is that you need to calculate the OIs. OIs are already been given in the data. Using them, you need to calculate EI, the expected frequencies, whose formula is N into PI. उसके बाद आप O minus EI का एक कॉलम बनाएंगे, यानी डिफरेंसेस लेंगे ऑब्जर्व्ड और एक्सपेक्टेड फ्रीक्वेंसीज का. उसके बाद आप उस कॉलम को स्क्वायर करेंगे और हर OI minus EI whole square को you will divide with its corresponding expected frequencies. So summing over that column, you would be obtaining a value of chi-square. And then the next step is to compare the calculated chi-square with that of the tabulated chi-square. Now students, table value जो आपको chi-square देता है, उसमें chi-square calculated must be greater than chi-square alpha k minus 1, where alpha is the level of significance and k is the total number of groups or categories. Either you use this formula, or if you have calculated the p-value of this chi-square, then you need to assess that whether it is less than alpha. If it is true, then you reject H0, and you make your conclusion. So you accept or reject H naught on the basis of the calculated chi-square and that of the tabulated chi-square. So using one of these criterion, you can confirm your hypothesis H naught or H1.